Hey everyone, this is Dr. Barengrutter. Apologize for the audio of this recording. It's a little bit weird using my headset. It's the only thing I have access to at the moment. I really want to get this video out while I have some time available to me. Anyway, this video is going to be an update on the orthodontic module as it relates to clear aligners and some of the bigger updates in the software as it stands. I actually already recorded this video about a week ago, maybe a little longer. Anyway, it ran on way too long. There's so much to potentially cover, and I struggle sometimes without sticking to the basics. So I'm gonna do my best in this video to stick to the facts, the normal workflows, and just to show how to use the software. This is not about, wow, here's a great case, let's talk about it specifically as it relates to this. I just want to show you the workflow. I'm going to try to cruise through here. If you're new to my channel, take an opportunity to subscribe, hit the bell at the bottom if you want notifications of new videos as they come out. Other thing is take a look at the progress bar at the bottom. You're going to see little chapters. The idea is that you can advance to whatever chapter you find is needed at the moment. You know, you might watch this video and feel like you've got everything down but one specific part, and you want to quickly access that. Rather than giving you a list of 12 videos to sort through, I'm going to give you one video and just break it down. And if you look down in the description on YouTube, you're going to see various chapters, the period of time, and you can click on that next to whatever portion you're looking for, you know, whatever section of the software you're looking for. So without further ado, I'm going to try to jump into this. So a couple of things right off the bat. We are in the main menu of the software. If we come up here to the Tools section, this is an important thing to know. From the Tools, Preferences, and this is going to bring us up a bunch of settings that we can dictate on the software. I'm not going to go through these. I'm just going to show you that they're here. This is for orthodontics. This is for your tooth movement limits, how quickly teeth are allowed to move, whether it's tipping, rotating, torquing, whatnot. And so as you use the software, you may decide that you want to modify these numbers. Have at it. It's up to you. This software gives you the ability to manipulate a lot of things. So anyway, I'm going to keep moving on from here. All right, so let me go ahead and just click cancel, okay, whatever. We're going to jump right into orthodontics. And I didn't mention this yet. If you want more advanced specific content, check out a course. Check out online. I've got online courses. I've got in-person courses at times. I've taken a break from that lately for a variety of reasons, but keep a look online at the very least, or look out for courses coming up in the future in person if that's your thing. Okay, orthodontics. We're going to click right here on orthodontics, and we're going to go into aligners. We're not going to go over to inert bonding trays. If you understand the aligners workflow, inert bonding trays is far easier. Okay. Clicking on here. Now here's a big difference from my previous videos. We are not going to jump into important models. We are going to start using this patient CT scan, and you're going to see why. You're going to see why this is invaluable and what sets this software apart, making it better than just about any software out there, to my knowledge, giving you some capabilities that are just not there until now. Okay, click on Import CT Scan, and I'm going to go ahead and I have a case all set up. I'm going to open this up. It's going to load this and whatever volumes are in there. Let's click OK. It's next going to ask me for the STL models, and give it just a moment. Oh yeah, sorry. We need to orient this. If your patient's looking way up, looking way down, make sure you level it out. Just kind of optimize this. Doesn't be perfect, but kind of just level them out where you think it should be. Click OK. That's an often missed step in surgical guide in particular, where people forget to optimize that. You don't want to skip that. So now I'm going to go ahead and click select this patient's models, and I'm using PLY models. It can be STLs, it does not matter. Click OK, and it's going to ask me, is this the maxilla or the mandible? Yes, it's the maxilla. And now it's doing a process that you're not used to. It's going to be segmenting out all of the actual teeth from the CT so that we can see the entire root length and see the actual, well, the length of the roots, the anatomy of the roots, the orientation of the roots, and allow us to figure out where these teeth are actually going to move and how they're going to pivot. So we'll talk about that a little bit more later. In the meantime, I'm going to go ahead and pause the video. This doesn't take that long, but it's a minute or two, and just for the sake of efficiency, I'm going to pause the video here. Okay, and after it runs that segmentation, it's going to automatically align our STL model or PLY model or physical model, or sorry, digital model to the CT scan data, and we're going to check here. It doesn't have to be perfect, but well, pretty darn close. And there's ability to manipulate that, adjust that as needed. But this looks pretty darn good to me. It'll then do the same thing. The alignment, I don't even need to pause it. It's a quick process. It's going to align the mandible. And once again, I just looking through here. And there's different views to look at, but I can tell you this is pretty well aligned. All right, clicking OK. And now we are at the point in the software where most people are used to. Usually you bring it in and you set up everything to move forward. So I'm going to go ahead and just 1 second. Okay, and I've just changed the patient name so that we can go ahead and get moving forward. Now it's going to automatically mark the mesial and distal nodes on the teeth, which is the previous thing we had to do on our own. Now it does it automatically now. It is not perfect. It is improving with time. If you find a case that's really bad that you think might help the software engineers, go ahead and submit the case because they can plug that case in and help the software in the future to do an even better job. So we're just looking at do all these dots match up well, and so I'm just going to kind of optimize a few if any of them just seem off a little bit. And again, the more cases that the engineers and the software, the machine learning gets to visualize like what's right and what's wrong, over time it's just going to get better and better and better. All right, we can go ahead and click to mandible. Oh, notice one thing. Let me go back for a second. It skipped 2 teeth. It automatically knows to skip if it notices the tooth is missing. Whether it gets the correct premolars doesn't really matter, honestly. Whether it's first or second, they have the same movement limits. But just so you know, it will skip for you. All right. Now the lower it doesn't do as good a job on this case. Every case is a little different, so I'm going to have to kind of optimize these a little bit. It may seem funny, like, well, maybe you should just wipe them all off and start over. I actually kind of prefer having this give me a place to start and just kind of moving them to where I want. And yes, I'm having to move, most of the teeth, but I don't really mind it. It's a nice starting point. And then you get to a point where the rest of these teeth are all pretty darn good, in my opinion. So, whatever. All right. Now we're going to go ahead to teeth segmentation. Now, the software is going to actually segment out, meaning separate the teeth from the model. It's going to create separate little surfaces for each individual tooth. And this has been around for a while, but this just keeps getting better and better and better with time. So it used to require a lot of manipulation to get these separation lines dialed in, but now the software does a pretty darn good job of it, and it does it quite quickly. As you see, I have not paused the video, or I'm not speeding it up. I'm talking because I just want to show you how quick and effective it is. It's also closing the models. It's making them, I bring in the open meshes rather than a closed model. That's because the software is going to do it for me, and I actually think it's better to do that. That's a whole other story that I've talked about before, but in courses and whatnot, but it's not that important. Just bring in an open mesh is your best bet. And it's just about ready. Okay, see, so again, I could have paused it, but I figured I could get some of the words out and allow you to see real time how quickly it does this and how good of a job it does. Upper looks great. Let's look at the mandible. Honestly, it looks fantastic. I'm going to improve something only because I want to show you how to. It's really not necessary. I don't need to in any of these. But if you don't like something, you can move nodes around. You can actually take nodes and you can merge them together. And now it's together. You can also right-click and unlink, remove link. And now you've got 2 different nodes again. So anyway, if you need to improve things, it's always possible. You can also hold the shift button and actually draw a new line, but that's so rare that I need to do that. I'm going to move forward. Now in this step, it's going to create little lines that are basically like you were trimming a model and you want to get rid of all the garbage kind of down here. It's going to automatically create a little line around these. And again, we have these little dot nodes you'll see that we can move and customize. I'm not going to talk about that right now. I talk about in courses sort of where I like to have these lines to make them best. But I'm just going to move forward. Just know that you can move them around. You can right-click to delete them and do whatever you want to make the models look the best, in your opinion. Oops, I accidentally grabbed that one and moved it. Probably not a bad idea. I don't think it actually matters, but I have a, I won't say a pet peeve. It's just a habit of always kind of fixing it if it falls off the heels like that. Again, it's really probably not that important. I guess I've messed with it without doing it, and when I can force myself to do that, and it doesn't really change anything, but it's still a habit of mine. All right, that's done. Oh, and just make sure it doesn't creep up over the teeth. It used to occasionally do this. I don't really have a reason for that, but it doesn't do it that often anymore. I say often. I can't remember the last time I've seen it, but it's still a good idea to spin around and look, make sure none of the gingival margins are altered or overlapped, I should say. So now, as you see, it's just cutting away all the excess, and then it's going to reclose the model, and it's going to, based on the parameters that I showed earlier up in the preferences, it's going to extrude a base just a certain amount. What it's doing is it's giving us the shortest model possible to our liking. If I want it taller, I set a setting in the preferences so the model's taller. That's going to take more resin when printing. It's going to stretch your trays a little more when you're making them, which means the resultant tray is going to be slightly thinner. So that's something to be aware of. So there are quote unquote consequences to having really tall models. They print easily. There's some benefits to them, but for the most part, I think most of us would agree the shorter the model, the better when we're going to be printing a bunch of models. Okay, so now it is taking all those teeth. It's actually segmented the teeth from the CT scan as well, and it's now lining those up with these segmented out um, virtual teeth. They're both virtual, but from the physical model or the digital model, the STL model. So yeah, it's just about done with this. And I kind of like to let it just do its thing, let you guys see the real time. The only thing I didn't do is that first part that it was doing, and that's just because it was sitting there. It takes about probably 2 minutes of just sitting there, and it was a great excuse for me to check my messages and drink a little bit of coffee. Okay, so there we go. That was all real time, no fast forwarding. I just wanted you to kind of see it. So this is cool because now what we're seeing is we're seeing the actual roots of the teeth overlapped. And as I move a tooth, the root moves as well, which is going to show us what's actually happening when we're moving teeth within the bone and whatnot. We can see it down here. If I want to just, like, I don't need to see all these views right now. I can click up here on these little triangles. And now I can just focus in on this, and I'm like, oh, I want to see those other views again. Let's look. How much did I move this tooth? Okay, now you can't move them in these views, but you can kind of see, well, we're out of bone. That's the kind of thing we're looking for or trying to avoid, of course. If I want to move that tooth back, I can just undo by clicking this, or I can click reset tooth position, and bam, it's back. Notice that if you look down here in this sort of panoramic view, like maximize this, you might be wondering, well, why are all these teeth up here? Well, that is because the CT scan was taken open mouth. Let me click there. Where am I? Right. Oh, where are we at? Right now we are in occlusion positioning, so the teeth are in occlusion. If I click here on CT positioning, they overlap the CT. It's hard to do ortho mock-up when you have the teeth open because you don't know how the occlusion is going to be. So we have both options, and at any moment we can switch back and forth. Honestly, you're not going to use CT positioning much. It is a nice reference because the CT segmentation of the roots, if you have a case where these roots are really nubbed off and you can see that the CT actually has longer roots, it's not a bad idea to send that case in for the machine learning to figure out how to improve its results. But this one, I'm going to be honest, it's like spot on. I can't see anything that is of any significance that could be improved. But again, if you have one, go ahead and send it in. We're just improving the whole workflow. You can send those cases to plan@blueskybio.com. Okay, so let's go back to occlusion positioning. We've got a whole bunch of other things, jaw movement, where we can do different bites and things like that. But I'm going to skip ahead of that. Don't really need to see any of these views. I just want to show you them again. We're kind of done with it. So we're going to maximize this. And everything from here on out is going to be in this view. Now, notice that right now the gums are somewhat transparent. If I scroll down this view all the way down here, I can decrease that transparency, and it's going to look more like what you're used to. Okay, and we can hide the CT teeth. Now this is like the old school version, or not old school, but this is the version that we always been using without the CT teeth. or I can show them. I can show them, hide them, whenever I want. But that's that's sort of that. Okay. All right. Let's go ahead and talk about where we're going to go to first. Let's go to the snap to curve. So let's hide the opposing arch, so we can just show the upper arch. Now the this arch, this curve right here, is generated based on some algorithms the software runs, trying to figure out how to straighten out teeth, okay, or how it thinks we want to idealize. When you're missing teeth, it tends to throw this for a curve, no pun intended, and gives this weird shape to it. But fortunately, we can fix it. And also, in a software, in a version I'm testing actually right now, it's already greatly improved. So they figured that bug out. But to edit curve, we click here, and now I can just go ahead and move that in, move it up here, maybe move this back a little bit. And as you can see, it's pretty simple. Everything is symmetric, unless you want to uncheck symmetric, and now we can start just making things walk cockeyed. And then we can reset things if we don't like what we've done. And oops, reset. Let's move symmetrically. And this is, again, don't worry about how I position all these teeth. It doesn't. I'm not looking for perfection here. I'm just going to give you sort of a simple case right here. Okay, so we've figured out how to edit the curve, and we can always hide the curve if need be. And now we're going to go ahead and start moving teeth. One thing I like to do is I like to lock back teeth. I suggest you always lock at least one tooth on either side of the arch. For instance, if I don't do that, and let's go ahead and hide these CT teeth for a second. Let's go ahead and hit snap all teeth. It's going to align all the teeth, but if you notice this right side, it's shoved backwards. If I click right here, I can show initial position. This one has rotated a little bit or tipped out, but this is actually slid. My point is it needed an anchor, and it's trying to minimize IPR whenever possible. So it's just going to try to minimize the IPR that is required. So what we're going to do is first I'm going to reset all teeth. I am going to right click on this tooth and say I'm going to lock this one, and I'm going to lock this one. So just a quick comparison, when I hit snap all teeth, it's going to try to fit everything in within these teeth, and then it's going to have to force some IPR. And it's going to kind of try to balance it out. You'll see that it's between 0.2 and 0.25, but that's it trying to make everything as even as possible. Okay? So that is how the snap to curve function works. So of course we can always take teeth and we can tip them if we don't like, and we can modify whatever we want. In fact, you can come down here and you can say, you know what, I actually want to rotate this tooth a little more. Or that's just tipping it mesial-distally. And you can see the IPR value is changing. Say, you know what, I really want to do a little more IPR right in this specific spot because I know I've got sacrificial enamel. Or, you know what, I need to extrude this tooth. I can move it this way, or I can dial it in right here. So you can kind of work to your heart's content, getting things exactly the way you want them to look. Once you're to the point where you got things lined up, say you want to do some torquing of roots. Maybe you say, you know what, this looks kind of pigeon-toed here. If I right-click on the tooth and I change it to switch to torque, it's going to try to keep the incised ledge right where it is there, and I can just swing the root. Okay? And then maybe I'm going to do the same thing with this one. I'm going to right-click, and I'm going to switch to torque. And, okay, so that's a little bit better. Now I can go back to tip and say, you know what, I'm just going to tip this back a little bit to sort of optimize that IPR. And this is where the actual numbers, switch to tip. Using these over here, let's tip mesial distally. Let's go ahead and just say, and I'm just going to the numbers are balanced. Now, look at that. Looks pretty good to me. Hey, maybe let's go ahead and extrude this just a touch. Get those two incised ledges pretty lined up, and you know, those look pretty good. The IPR is, you know, pretty balanced out. A little bit more in the right in the midline. Do whatever you want there to, maybe we tip this distally just a touch. And now we're at, you know, we're perfectly balanced out in the IPR. So anyway, again, I'm not trying to show you a perfect case. I'm just showing you those are the sort of the ways we can finesse things along. Okay. So we can go ahead and move down to the lower arch as well. I'm not going to spend much time on this arch because I'm really just focused on showing you the workflow, and I'm not trying to show you how to get a perfect case. But one of the things I do like to do is show the opposing arch, then come down here and set this sort of slightly invisible, and then I can go ahead and edit the curve so that it fits well within the opposing teeth. Okay? And so then when I hit snap to curve, it's going to sort of line up in that way. Okay, so let me put this back to visible, and let's turn off the opposing arch. And once again, let's lock these back teeth. You might even lock both sets of molars if you're doing more cosmetic ortho. If you're doing cosmetic ortho, lock all the posterior teeth, and then just mess with the canines forward. It's going to make your life a whole lot easier, not worried about back teeth. But this is your option. I can click snap all teeth. And again, I didn't spend much time getting this optimized, but you can kind of see, all right, there we go. And then if you want to say intrude some teeth, okay, and we turn off the IPR if it's distracting. I know I didn't optimize the IPR. I might have messed them up a little bit, but you kind of get the point here. And I can say, oh, that didn't rotate exactly the way I want it to. Click on, if you want to hide this little gimbal here, just click on one of the lock teeth. It'll hide that. And then you can, I have no idea, this might look terrible, but it's actually not bad. Yeah, there's a little bit of crossbite here, so we need to optimize that, but again, I'm going to move forward. The one thing that I haven't shown you yet, and this is the part, I saved it for last. The previous time I recorded this, it was one of the first things I talked about. But I wanted to get through the general functionality first, because what's really important is that I show you these actual CT teeth. Because, and I need to make a note to myself. Okay, so I'm going to make a whole different section of the software to review this, because I think it's really important to understand. So let's go ahead and dial that back down to 50% on the transparency, so you can kind of see what's going on here. And notice that this pivot point, when I'm tipping teeth, look where it pivots about. It pivots right in the, pretty close to the apex. And the reality is, I don't agree with that. That's not where it's going to pivot. It's going to pivot somewhere in the middle of the root, slightly close to the crestal bone because the root is thicker there. But it's not the tip, it's not at the crest, it's not the gum line, it's the middle of resistance, which is somewhere along the middle of the tooth. Now, we are working on further advancing the software so that it can automatically detect these pivot points. But some of them are decent, some of them are not. This canine, yeah, it's just too far down. This central, not too bad, it's off center. Look at this premolar. I think this is one of the ones that the pivot point, well, it's way too far lingual. Let's see if I can find one that's really bad. Not too bad. Oh, there you go. The pivot point's practically outside of the tooth right here. It's because of the root curves, and so the software doesn't know that. Control Z to undo that. What I can do is I can refine the midline, and I can say, all right, well, you know what? Vertically, it's probably closer to there. Midline, probably closer to there. And then along the long axis of the tooth, it's probably right there. Okay? Oh, and tipping wise, it's probably right there, or mesial distal tip right there. So now I know that when I actually tip this tooth, oh, one more thing. It's actually probably a little more this way. There you go. That looks to me about the middle of the tooth. So now when I tip it, I feel confident that that's really where the center of resistance, the center of rotation is going to be. So I'll do one more out of this canine just to show you one more example of this. So I hit refine midline. I can just go ahead and bring this down a ways. So incisogingivally, I'm pretty confident in that. Mesial distally, pretty good. Buccolingually, pretty good. And then tipping, mesial distal tip wise, there we go. It's pretty well centered. And there you go. Now, if I want to move the next tooth, I can just keep clicking and adjusting, clicking and adjusting. But the point is now I know when I snap this tooth to position, or let's turn this off. When I snap this tooth to the curve, it's going to go according to, the actual proper center of rotation, whereas before it just wasn't. Okay, so let me. I'm just going to manually adjust this one just because I don't want to spend the time tweaking things around too much. Let me just go ahead and hide the opposing. So this PR and oh, it's because I reset. Okay, I need to snap all teeth because I every time you reset the curve, the midline, it resets the tooth. So everything's kind of out of whack here. These two teeth are still locked. I'm going to go ahead and just say snap all teeth. Okay, and we'll just say, you know what, this is good. I know I did earlier. Adjust this and adjust this, and we'll turn off these CT teeth. I'm not going to worry about those torquing movements just because it's just not relevant really to this video. Okay, so at this point, I'm going to move forward to editing steps. But before we do go to edit steps, I forgot to mention limits, monthly limits. And this is an important thing. There's listed as monthly, biweekly, and weekly. Let me explain one thing. I talked before about how up here in the tools, preferences, tooth movement limits. This is how much movement is allowable in each whatever direction, whatnot, per month. Okay, does not matter how many trays, how often you change the trays. It's the same amount of movement. How much, basically the idea is biology. Is it degrees or millimeters? How much can a tooth move in a month? So with monthly limits, that just means you're going to get one tray per month. It's going to break the movement up. If it's a 6 months worth of treatment that's required, then it's going to be 6 trays. If it's 6 months of treatment and you want biweekly, you're going to have 12 trays. If it's 6 months and you pick weekly, you're going to have 24 trays. So the idea is, do you want to break down the amount of movement accomplished into small amounts of movement or into medium or large? So I would call monthly aggressive because it's a lot of movement packed into one tray. Whereas weekly I would call conservative, very little movement per tray. But you're going to have 4 times as many trays. That means 4 times the labor and material cost. And the tedium of changing that often. I will also tell you that you might say that, you know what, I think that teeth can move faster. And rather than changing all the preferences, I'm just going to say I'm going to give the patient, I'm going to set it up as biweekly, but I'm going to tell them to change the trays every month or every week. And that way I'm actually moving twice as fast. I'm not advising that. I'm just telling you that's how you can control speed. If you think things can move faster or slower, that's how you can modify. Just increase or decrease wear time. This limits right here is all about breaking it down into the number of trays you want. Okay, so I'm going to leave it at monthly. We're going to continue to edit steps. And because I didn't even mess with the lower, I'm not even going to look at the alignment sequence for that. If this right now is showing me that it's from the initial step, that's be a 0 step. If you have buttons, it'll be where you put your buttons on. And then steps 1 through 9, all the way to the final position. That means there's 10 total treatment steps. So if I want to see that movement, I can kind of just move through here. And I notice that the tooth that needs to move the most is that lateral incisor. So it's moving first, then that premolar starts moving, and then other things start moving. That is because down here it says least movement last. If I change this to least movement first, it's now going to do the opposite. Everything's going to start moving, and then the only teeth still moving are those other teeth that just need the most amount of time. There's different benefits to different things, okay? So what we're trying to do is avoid mid-treatment collisions. For instance, our final position right here is supposed to have 0.2 millimeters of IPR. Sorry. If I go to right here, it gets to 0.3, gets all the way to 0.35. And meanwhile, it's got a diastema over here. So we're trying to avoid that collision because that would require me to do a bunch of IPR just to make those teeth pass each other. Meanwhile, I've got a space on the other side. You might not actually need to. With that diastema, the tooth might just push back there and flex the plastic a little bit. I'll tolerate that up to up to a maximum about zero point 0.1 millimeters, but that's up to you. I'll give it a little bit of slack, but in this case, I think that let's just go ahead and see the other way around. You see that 0.45. The final position is 0.1, and it gets to 0.45 right here. And I don't really have much space to move it to. I mean, there's things I can do, but I think the other way is going to be easier for me to fix. There's also a 0.5 right here, and there's just more complications. So you just kind of pick which one you think is going to be the easiest to refine, because that's what we're going to do. We're going to refine this until we get it where we want. So let's go ahead and just fix that one. So what I'm going to do is I'm going to go to here where it's 0.3, and I'm going to say, okay, we're going to tip this tooth back just a little bit. Hit refresh steps. And now let's see what that looks like right there. It skips that. In fact, it fixed everything, because now it recalculates how to move from me putting it here to that final position. And it says, well, I don't need to go back into that high IPR, and it just corrected it. So I am effectively done. Now, notice that right here there's a 0.35, and there's a diastema. And then it drops back down to 0.15. So there's one more thing we need to fix. Easy to fix. Click on this tooth. That works for me. Hit refresh steps. Sometimes in doing that, you're going to add steps, because sometimes it takes more time to get to that position, and that's fine. It's not like, oh, I'm making treatment longer. No, the treatment you were proposed was never possible because it required collisions that just won't work. But now, there we go. That fixed it. I'm going to show you this spot right here where it's 0.25 at the end, and it does get at one point to 0.35. I might just ignore that personally, but since I know that on the other side of the tooth I've got 0.25, and at that point I've got just 0.1 right there of IPR, I'll go ahead and fix it. I don't need to. I think that it'll probably just accommodate in the plastic with that little bit of IPR. But let's start here. Let's hit refresh steps. And now let's see if it needs to end up at 0.25. Does it ever get above that? It doesn't. So in that little bit of work, I've now refined the movement evaluation, or this is the movement evaluation panel. All right. Now we can also export a video if we want to send off to, like, if you're a lab, you're sending off to your provider, or if you're showing your patient, you can kind of work from there. There's also the ability to duplicate steps down here, and the purpose of this is to allow you to set sort of waypoints. This is definitely advanced level stuff, so I'm not going to cover this. I'm just telling you that you can take a step here, you can duplicate it, and then you can move one of the different duplicates around and allow you to have various waypoints. So it gets pretty complicated, but that is there at user request. We are going to add buttons. You have the ability to actually design printable aligners, and that way you can actually just export liners and print them. Now, I'm not trying to sell you on that because there's shortcomings to that material science-wise, but the software is completely capable of it, and it is the only, to my knowledge, software that is FDA certified for that process. There are some other softwares that allow you to do it, but they haven't actually been through the FDA process, which is a lot of work, and it took a couple of years, if I recall. Yeah, it was a couple of years to get that all done. And then you can also just export the trim curve if you want to use a milling machine. Some milling machines will basically thermoform and cut the trays for you, so that's what that's for. But we're just going to do we're going to export the models, and we're going to add buttons. Now the software is going to dictate where the buttons should be. It knows this tooth needs to extrude, it needs a button. This tooth needs to rotate, it needs a button. This tooth needs to torque, whatnot. Not every movement requires a button. But it will always overdo it with regards to buttons rather than underdo it. And I like that, because it's very easy to remove a proposed button or to slightly move a proposed button. Better than me having to add them all myself. In the past, we had to manually add each button, and again, I just rather let the software sort of dictate where those buttons should be. And using a lower, I didn't look at the movement sequencing, but it has a button on every single tooth. And they are, but believe it or not, they may look all identical. They're actually positioned according. You see, this one's actually vertical slightly, and then Same thing here. They're there for different reasons. These were all these teeth are being intruded. So a tooth doesn't need a button to be intruded. It needs buttons on its adjacent teeth to anchor the tray to keep the tray from popping off while it's intruding. A tooth that's being extruded does need a button. That's why these two laterals have horizontal rectangles. It's to pull those two teeth down. These teeth are being rotated. So were these. If I had to put those torquing movements like I did initially before I mess with everything, these would need buttons for that. So again, if you're like, you know what, honestly, I think this tooth will rotate just fine without this canine, I just right click on it, sorry, and remove it. Easy enough. If I say, you know what, geez, I want a button on this tooth because I want it to lock the tray in better, you can always just right click, sorry, add button, and we've got a bunch of different buttons to choose from. These aren't going to use for aligners so much, but they're showing you what an elastic button would look like. These are your standard buttons, vertical, horizontal rectangles, triangles, and then your more advanced buttons like cones, sliced ellipse, and then wedges. Wedges can be used for bite opening cases or for for intrusion, but also used for leveling the bite, deep bite cases. And they can also be used for extrusion and whatnot. So you can dictate the size there, but if you can also always just grab a hold of these little nodes and scale the nodes to your liking. The little dimensions, the numbers tell you where it is positioned on the tooth, and that's about it. Okay, so we've shown everything. We can go ahead and move forward. Again, I'm not even going to look at the mandible in this video. I'm staying on track so far. I'm at 36 minutes. Last time I did this, it was right at an hour, and I'm really trying to avoid that. Okay, so now, I don't love this canine position, but whatever. All right, let's go ahead and let's just hide this. We're working on the maxilla. The software will, by default, add a platform. If you're going to print your models horizontally on the print bed, I would just remove it, but I print models vertically. So I just unlocked it because this is going to allow me to scale it. Grab these little nodes to scale, the arrows to move. And I'm just scaling it so that it's as wide as the heels and there. And I don't need it any taller because this little part here doesn't serve a purpose. And there we go. So now when I print the models, I can go ahead and lock this. They'll print just like, well, they'll be hanging upside down technically, but they'll be printing like this on the print bed. Doesn't have, there's a slight overlap over, ledge there, whatever, it doesn't matter. Now, some people like to use this separation slider right here, and you can separate it into two different ones. I used to do that. If you watch my videos on YouTube showing how to make trays and how I just show that, we talk about this in the courses and whatnot. When I make trays, having this entire platform is actually really beneficial for my workflow that I have my assistants do, and it is very efficient, making trays very quickly, and can be done in under a minute as far as trimming the trays and getting it all ready. Typically a couple minutes as opposed to 5 to 10 minutes as it can be. Lastly, so we've got the platform positioned. We need to add a name. I am going to turn on the label, and I'm going to make sure it's on engrave because I want to cut these into the model, not have it stick out. And because I no longer print my models hollow, which is an option to do up in the parameters, I can have this. If I make hollow models, I can't have the labels here. It'll get rid of them. So you'll need to put them on the borders of the models like this, which is fine. I stopped doing it because it was tedious, always trying to find a spot to do it. But I guess I'll just go ahead and do it here since that's where I'm at. So it is going to emboss a label for every model, and that way when you print it, you know what tray you're making for what. You can add a number to an actual tooth. Just delete the patient's name and hover the number over top of the tooth and have it emboss it so it sticks out. That will allow you to sort of mark the trays with a number. I don't do that, but that is something that I used to do years ago, but I don't see the need anymore. So at this point, we've got our platform optimized. We've got our label added. We can go ahead and you can export a video again if you want. A video is not bad to have it for your own reference if you're doing the treatment yourself to kind of see how teeth are supposed to move. But you can and you can check the different models. But that's also there's so many models because it includes the lower has 19 trays. That's why it's showing more. So here's the first whatever, 10. We can also go ahead and create a report. Export is there, but I'm going to show you that in a second. It generates a quick report. I'm just going to throw it on my desktop. Where's my desktop? There's a game bill. I'll just throw it in there. And I'm going to show you what it looks like. It's just a very simple PDF that shows you the IPR values at the end of treatment. And it shows you how much IPR is done as of stage 1. And then it will say, well, as of stage 2, there should be this much. And as of stage 3, be aware, it's as of. It's a cumulative number. It is not a, we need to do an additional 0.25. We need to do additional. No, it's at this point, you should have done up to this much for those trays. So what I would suggest, because I like to get the first 2 trays, is you go down to stage 2 and you get at least this much done. Okay? That will make sure that you have enough to get those first 2 trays in. Personally, I tend to just do all of it. Now, I always underestimate it by about 0.05. So I'll do 0.2, 0.2, 0.15. I'll just dust the contact, 0.15, 0.2, 0.1, 0.215, 0.2, 0.2, 0.2. So I'm just, I'm doing just a little bit less because I can always do more later in treatment, but I'd rather err on the side of doing too little rather than having open contacts. The software also, if this number is actually 0.17, it says 0.15. If it's 0.22, it says 0.20. Some software, most softwares, to my understanding, round up because they don't want you to get into collisions where you can't proceed because then their software looks bad. But you look bad when you have a bunch of open contacts everywhere and everyone's getting food caught in their teeth. I would rather err on the side of caution. So like I said, and that's how I asked the engineers to make it, is to have it underestimate, or under display, I should say. Okay, so we've got the report, and now we need to export. Now it's going to first say, did you add a platform? No matter what, it's going to ask that. Did you add a patient's name and number on it? Yes. You can click this if you don't want to see this warning. Don't do it. Just don't. I've been designing cases like this for years. 5 years? No, 6 years. 6. Yes. Geez, I'm on my 7th year designing. I think 7th year designing cases with this software. I want this shown every single time because all I have to do is say yes, proceed to export, and I can export the models and get them printing. It's just too easy to forget, and I still forget occasionally. Oh shoot, I forgot to optimize the platform. Oh geez, I can't believe I didn't put a patient's name on it, or I did the upper but I didn't do the lower. Just let it remind you. If you're using sprint rate printers, you can actually check this box and it will automatically push all the models. It'll export them as well. As long as you have that checkbox, but it will also push the models right into Wayware. If you're doing like a 6 model case, well, it's not a bad idea. Just go ahead and print them and be done. If you're doing a 12 model case, I don't like to print that many because what if they get halfway through treatment and things aren't going right? That just happens. Ideally, we're going to have better movement with these, with the roots visible because now you know how they're actually supposed to move, but there you go. All right, and that's it. So 43 minutes and change. Hopefully this was a useful video for you guys. Again, please go ahead and subscribe, hit that notification bell if you want to be notified. I don't care, but I think it's helpful if you want to see these videos. If it's going to help you to get more efficient, that's my goal with making these videos. Please let me know in the comments if you have any questions, and be sure to check out my website, bearingrudderDDS.com, for more content, for courses, for other videos, for other supplies, things that I use in my office if you need some help with that. So, all right, thanks so much for listening, and I believe that's it. All right, bye for now.